Okay, now we're going to talk about the addition rule and complements, which is really cool because we already kind of touched on complements in the previous lecture. So again, first I'm going to start off with some definitions. The first thing you need to know is about disjoint events. Okay, so let's say you had disjoint events, and also you'll also hear them called mutually exclusive. Oh, the events are mutually exclusive. That just means that they're disjoint, okay? Disjoint means that they have no overlap. The events have nothing in common. Okay, so when you think of two things that are disjoint, you're either a man or a woman. There's no overlap. You can't be both. You can't be born both at the same time. You're either a man or you're a woman. You're either a freshman or you're a sophomore. You probably can think of more than I can. But the thing is, there's no overlap in between them, okay? So events that you can think of is, what's the probability of me flipping a coin and getting heads and spinning a spinner and getting blue? They have nothing to do with each other. So those would be considered disjoint events. And to find the probability of disjoint events, you would just take the probability of one event and add it to the probability of the other. Okay, so let's look at a problem. Let's say, for example, that I have a deck of cards, standard deck of cards, 52 cards, no jokers. And I want the probability of getting an ace or a 2. Okay? There's no such card that is an ace and a 2. You can't be an ace and a 2 at the same time. So these events are mutually exclusive. They're disjoint. Okay? So then that's easy. The probability of me getting an ace, there's, how many aces? There's 4. There's 4 aces. There's 4 aces out of 52 cards. Plus 2, aren't there 4 twos? There's a 2, deuce of club, deuce of diamonds, deuce of spades, deuce of hearts. 4 out of 52. Okay? And then if you add them together, they already have a common denominator, so that's 8 out of 52, which reduces down to 2 out of 13. So there's a 2 out of 13 chance of me getting an ace or a 2. Okay? And you could just add the probabilities together because they're mutually exclusive. Okay, now this is really important. This is not mutually exclusive. Non-mutually exclusive events means that you have an overlap. You have a chance of something being both. For example, a mom and a woman. Well, I'm both. I'm a woman and I'm a mom, right? But you could be a woman and not be a mother. You could be a mother and not be a woman. Like, I'm saying like a human woman. Does that make sense? You can be like a whale, a female whale, and be a mom, and you're not a human woman. Does that make sense? So you have an overlap in between. Well, if you have those type of events, then the probability of the event E or F happening would be the probability of E plus the probability of F, and you would have to subtract the probability of E and F because you're counting them twice. Let me show you in an example. Okay, let's say I had a standard deck of cards again, and now I want to find the probability of me picking a heart or picking a king. So then you ask yourself, are these events mutually exclusive? Are they disjoint? And the answer is no, they're not. Because there is a card in the deck that's both. There is a card in the deck that's a king and a heart. Does that make sense? So that's what you kind of ask yourself. So then the probability of me getting heart is 13 out of 52 cards. The probability of me getting a king is 4 out of 52 cards. You just counted that king of hearts twice. You counted the king of hearts here, and you counted the king of hearts here. So then you have to subtract 1 out of 52. There's one card in there that's both, that there's a king and a heart, and you have to subtract that. So 13 plus 4 is 17, minus 1 is 16 out of 52, which reduces down to, I don't even know, 4 out of 13. So 4 out of 13, that is my probability of getting a heart or a king. Okay, does that make sense? So it's really, really important that you learn how to identify mutually exclusive and non-mutually exclusive events because it affects what equation you use. Okay, I've already explained complement, but I just saw it anyway in my math lab. You have a probability of an event happening, so the probability of it not happening can also be denoted by e to the c, like little c above, meaning complement. Now just remember, all you have to do is tell me what's not in the set, or if you're actually talking about probability, you can just subtract from 1. Like if the probability of something happening is 30%, then the probability of it not happening would be 70, because I just took 30 from 1, 0.3 from 1. Okay, and then you can also just tell me what's not in a set. For example, if I said, hey, the sample space is 1, 2, 3, 4, 5, and 6. And then I have a set where E is 1 and 2. Then what's the complement of that set? And the complement of that set would be 3, 4, 5, and 6, because I'm asking you what's not in E. Well, if this is the entire sample space and E is made up of 1 and 2, then what's not in the set would be 3, 4, 5, and 6. Pretty easy. Okay, let's say a social worker had some cases, a caseload, and she's dealing with children under 1 year old. She only has 1 of those cases. With children between 1 and 5 years old, she has 7 of those cases. 6 and 10, she has 6. 11 through 14, she has 8. And 15 to 17, she has 4 cases dealing with children of that age. And then I asked you, hey, what's the probability of her having a child that is less than 1 year old? Her next case, what's the probability that she has a child less than 1 year old? Well, if you're basing it off the data now, wouldn't it be 1 out of 26? Because she has 26 cases total. I add them up. 10, yeah, it's 26. 1 out of 26, which is approximately about 0.038. And then I were to ask you, hey, is that unusual? Is it going to be unusual for her to get children that are under 1 year old? Okay, and so some of y'all might be wondering, well, I mean, it's low, it's a low probability, but how low is too low? Does that make sense? Like, how do I know if it's unusual or not? And I just wanted to give you the heads up. If the probability is less than 5%, if it's less than 5%, then it's considered low. Okay? That's why y'all should totally figure out what the probability of you winning the lottery is. I guarantee you it's less than 5%. It's low, okay? So that would be considered unusual for her to get another case where she's dealing with a child that's under 1 year old. Okay, you guys, so that's pretty much it for complements in the addition rule. Just remember that it's really important to identify, just to be able to identify if an event is mutually exclusive or not, and then you just know what formula to use, okay? If you know that they have something in common, then they're not mutually exclusive. Does that make sense? If they have something in common. If you see an and, if I say, oh, the probability of this and this happening, then that means that they have something in common. Okay, so you would have to subtract that piece from the events individually. If you have any questions, just feel free to let me know.